Cut.
We are going to be doing problem 1.8.36 from the book. All that it wants us to do is prove, I should probably be writing bigger.
Actually, it's pretty good.
Prove that the cube root of 2 is irrational. We're going to prove this in a similar way that we proved that the square root of 2 was irrational, which means that we're going to prove it by contradiction. So what we're going to do is we're going to assume that the cube root of 2 is rational. What do we know about rational numbers? Rational numbers can be expressed as a ratio of A over B, where A is included in the integers, so it's all positive and negative whole numbers, and where B is also included in the integers, but it is not 0. So, if we assume that the cube root of 2 is irrational, and we know that, if we assume that the cube root of 2 is rational, and we know that rational numbers can be written as in the form of A over B, all that we can do is say that the cube root of 2 is equal to A over B. Starting to manipulate this formula a little bit, we see that 2 is equal to A over B cubed, which can be rewritten as A cubed over B cubed. Continuing to manipulate the formula, we get B cubed 2 is equal to A cubed, which can also be written as 2B cubed is equal to A cubed. What's happening here is that we assumed, this is a contradiction to our original point, because we assumed that A over B did not have any kind of common denominator. But in order for 2B cubed to be equal to A cubed, A must be an even number. So, therefore, the cube root of 2 is irrational because A cubed and B cubed are in 2B cubed cannot both be even numbers. And yeah, I'll go ahead and, I remember one of my old math professors always liked to circle the answer in a different color, so I'm gonna circle it in green.
Sounds good to me. Okay.